Good. So we finished the chapter on linear momentum, chapter 7. Today we're going to do this projectile motion 1, and there will be a quiz for the projectile motion as well, right? We spent several weeks without doing any quiz, so let's try to make up for this time that we didn't have any quiz. The quiz is going to be similar to, the quiz is going to be like have 5 questions, right? That's how we did before. Let's see how we did before. Quiz number 9. Quiz number 9, yeah, just like quiz, it's going to be just like quiz number 9, okay? 5 questions, and you're going to have like 20 minutes to do that, okay? More students coming in. So get ready for the quiz. The quiz is going to be on the lab itself. Notes, lab notes, here you go. So here you go. Today, first thing, right? First things first, reports for lab 2 and 3 are due now. Don't forget to load both Excel and Word document. Today is October 26th. And okay, what I'm going to do, I'm going to post this lab number 4. Download information. Yeah, lab number 4 today, right? So I'm going to upload an Excel file with the data for today's lab. Let's see here, what's going on here? Okay, that doesn't apply. That doesn't apply. So there you go. Download. Okay, let's see. I will upload the data for your lab report for your lab. Okay. Let's see what I gotta do here. Today, who's the report for lab 2 and 3 are due now. Don't forget to label both Excel and Word documents in the proper format. Here you go. I didn't finish item number 1, right? Let's finish item number 1 here. P06L02 and P06L03, respectively. Both the Word document and the spreadsheet must have this format, okay? Today's lab will be lab number 4, projectile motion. Okay, I will upload the data for your lab, bear with me. And that's gonna be, the data that you're going to, I will upload the data for this lab to your group folder. Okay, the file is going to have this name, P06L04GYY, right? And take a look again here at the syllabus, lab number 4, projectile motion. Don't forget, exam is going to be next Wednesday. We have plenty of chapters to cover, right? 3, 4, 5, and 6, because we have lots of material for the chapters. I will leave the I will not ask you for labs 2, 3, and 4 in the exam. Okay, I'll leave that for the exam number 3. Okay. Just a reminder, exam is next Wednesday. Chapters, exam 2 is next Wednesday. Chapters 3 through 6. There will be no questions for the labs, but you should expect them. In exam 3. Okay. Not this one. We can erase this one. Let me work on the spreadsheets now. In this meantime, I recommend you to go to my YouTube channel. Here you go, and start watching while I prepare that. Go ahead, go to my YouTube channel. I'm gonna give you a link. Okay, start watching this video that explains the lab that we're gonna do. Okay, so and then I'll catch up with you in a minute. See, make sure that's the one. Yeah, that's the one. Okay, that's the one. Okay, thank you. Start. Start watching the video in the following link. It's just a 15-minute, 17-minute long video in the following link. Okay, and while you do that, watch on your side. I will upload the spreadsheets to your group folder. Bear with me, please. Oops. 22. We're in the fall. We go group folder right in here. Yeah, this one right here. That's good. So good. 2 more students coming in. Oh, why do I have see. So something strange happened here, right? Oh, I see. Now I understand. Now I know what happened. Good. Sometimes we make a mistake and we don't even know why we made the mistake. If you're paying attention, right, you knew what I'm talking about. You know what I'm talking about. So here you go. Group 1, you have your spreadsheet there. Group 2, you have your spreadsheet there. Group 3, spreadsheet there. Group 4, spreadsheet. Group 5, Group 6, Group 7, Group 8, and Group 9. Good. Okay. So just revising what we said, right? So here you go. Reports for lab 2 and 3 are due now. Make sure you upload them to, both the Word document and the Excel spreadsheet. Make sure you upload them to your group folder. Let's see, lab 2 and lab 3, right? I can see Vanessa Bonilla here. Okay, hi Vanessa, make sure you take out those numbers here at the end, okay? Please do that. Oh, don't forget, I don't see the Word document here, Vanessa. Okay, I don't see the Word document here. I see this, but not the Word document. So here you go. Lab 2, okay. Group 2 uploaded both the Excel and the Word document for lab 2, but I don't see the Word document for lab 3. Okay. And March.
It's uploading right now, Professor.
Okay, thank you. And if you may please, change the. You can delete this one, right? You want me to keep this one, right? Is that Mia who spoke?
Yes, Professor.
Okay, good. I'm gonna delete this one, right? You want me to correct this one, right, Mia?
Yes.
Okay, so I'm gonna delete this one. And I don't need this one either, right? So go ahead and upload. Okay, so for whoever arrived a little bit late, make sure you start watching the video in my YouTube channel. That's for today's lab. Okay, I'm sending that link again. Projectile Motion. It's just a 17-minute long video. Let's see, group number 3. How are you doing that? Group number 3. Group number 3. Hi, Joshua. Let's see. Yeah, I don't see lab 2 and lab 3 there, Joshua. Okay,
yeah,
let me know.
right now I'm working on submitting the lab 3, but for lab 2, I wasn't able to take part in that one since I wasn't in the lecture, so that's waiting for my group to upload that one.
Okay, so you're gonna upload the lab number 3, Joshua. Okay.
3, yeah.
Don't forget the Word document as well.
Mm-hmm.
Group number 4. Let's see, group number. Okay, here you go, group number 4. Do not put this extension here, please. Okay, Lily. Just and remember, I'm gonna correct only one lab report. Okay, so decide among yourselves which one do you want to keep it here. I see group lab 2 here, right? I see 2 spreadsheets for lab 2, groups for lab 2, and I do not see the spreadsheets for lab 3, right? Did you? Let me check here. And I do not see. Oh yeah, so that's okay. That's good. So this one is good. Now I need the Word document for lab 3. Okay. Yeah, they put. They still have me, right, Claudia Galon, as the owner of this lab report. Group number 5. Let's see. Group number 5. I don't see lab 2 here. Huh? Okay. Okay. And don't forget to put the Word document as well, right? You need to put the Word document as well. If you don't put the Word document, I'm going to subtract. I usually subtract like 10 points from your final grade if you don't submit the Word document. Next. Meet. Okay. What was the last one? Group 6. Next one should be group 6, right? Lab 1, lab 1. I'm going to start putting a new folder so this folder doesn't become too crowded. Okay, old stuff. I'm going to put like old stuff. Okay, I'll try to do that for everybody, but only for lab 1. Okay, here you go. Lab 1 here. So we go move. Okay, lab 2, 3. Okay, now we have 2. No, why do I have lab 6? Group 6 here. It looks like I accidentally. Yeah, I accidentally put the group 5 here. Right? Less modified. Doesn't make any sense. Why is April 14th? Huh? Okay, I'm going to delete that. I'm going to remove that. For some reason, I do not know why group 5 went to your group folder. Let me see here if group 5 has it. Group 5, yeah. Yeah, I don't see lab 4. Okay, group 5. I'm gonna get you lab 4 there for you. Group 5. You go. Okay, good. Now you have there group number 5. I misplaced lab number 4 of group number 5 into group number 6, right? So here you go. Group number 6 has lab 2 here and lab 3 here. Good. Thank you, group 6. Let's go for group 7. And again, I'm going to, old stuff, right? Yes, old stuff. In the completed folder. Don't put in the completed folder, okay, Basilio? It's easier for me to, let's see, I'm gonna move to the original place. But before we do that, let me put the old stuff there. Everything that's lab 1 related, I'll put there. Okay. It's easier for me to. Okay, now we do not need 2 and 3, right? Because we submitted the complete lab. Those are the original file that I sent to you. Yeah, that original file I sent to you. Yeah, you can see that there is no units there, right? So that's why I know it's my original file. So we don't need that anymore. And now I'm going to move those files here, group number 7, and let's do this way, okay? Move to here. Move here. Move. Okay, and now I don't need the completed lab folder anymore. 2 and 3, that's good. Group 7 managed to do that. And group 7, group 8. Let's see, I'm going to create old stuff file folder. And only everything related to group 1 goes here. Change who has access. Will be visible to everyone who can. Okay, you can see old stuff. This I will be visible. Okay, move. Now, lab 2, good. And lab 3, good. And then you have lab 4 here, group 8. Now we have group 9 as well. Yeah, new folder, old stuff. Isn't that nice? We can do that today, right? Now let's see, here go, HTML. Okay, everything that's lab 1 is moved here. Okay, group 9, I see Excel spreadsheets for lab 2 and 3, but I do not see the Word documents for lab 2 and 3, okay? So now we are in good shape here, and then I will take care of the other groups later on, okay? So you have your spreadsheet there. Exam 2 is next week. Let's see here. I will. Okay. So now that I have already uploaded, right? Download. Download. Spreadsheet. Lab 4 spreadsheet. Lab 4 spreadsheet from your group folder. Okay. If a reminder, I should put this reminder here at the top. Exam 2 is next to Wednesday, chapters 3 through 6. There will be no questions for the last, but you should expect lab questions Labs 3 through 4 should expect the labs 3 through 4, labs 2 through 4, at least, right? At least them. At least in exam 3. Start watching the video for lab 4 in my YouTube channel. Okay, I'm going to copy and paste the link again for those who arrived late. Here you go. That's the video for lab number 4, projectile motion. Okay, we don't need that. We don't need that. Okay, and that today's experiment is projectile motion. Let's see here. I believe there's another link for the same video. Let me check. This is old notes of mine, right? Let's make sure that's the same link. Shorter, right? It's easier to handle it.
Sua produção ainda atrasa por causa de falhas inesperadas. Acompanhe suas máquinas em tempo.
No, that's not this one. Okay, that's another one. Okay, this is another video that we're gonna look into that. So this video about photogate, okay, and I will video about the photogate. Okay, that's a good one, so you can have a better idea how the photogate works. If you haven't worked with it, you do not know. You don't have a clue how it works, right? Okay, so what we are going to do? We are going to verify the equation of projectile motion using actual data collected in the classroom. Everything must be in terms of the main SI units or their combination, right? So, you know, review the video for lab 4 experiment, right? In my YouTube channel. And I'm going to walk away from my computer. I'll be back shortly while you review this video. Okay, that's only 17 minutes long. I'll be back shortly. Good, I'm back here. And I'm gonna walk you through this experiment. Let's watch together the video, right? Let's watch together the video. And if there is any need, I will pull up my other documents here. Let's see here. Here you go. That slides. Projectile motion. That's the slide that you have seen there in the video, right? I'll keep it here for you in case we need. And at the end of this presentation, we're going to do a quick quiz, okay? 9:20. So okay, what's the equipment for today's experiment, right? Well, first, what we have here, in order to come up with a projectile, we need some device to project the projectile, to propel the projectile. And what we use, right, in this experiment to propel the projectile is a spring-loaded gun, okay? So we have a very strong spring that goes inside the gun. We loaded it, we load the spring, and there is a trigger mechanism to release the spring. And once we release the spring, the projectile is propelled, okay? Can you picture that? Here you go. Here you go, that's the projectile launcher. There is a spring here inside this device that's not seen, okay? That's not shown. And what you have here is a rod of the projectile that becomes shorter when we load the gun. Right now, the gun is not loaded. The spring is not loaded. Okay. And well, we use a bubble level. Carpenters, that's a standard instrument in any construction. Carpenters use that, scientists use that, everybody uses that. Okay, the bubble levels are the simplest type of level that we have out there in the market. Now they start to manufacture laser levels as well. Okay, and the projectile is a sphere, a steel sphere. Is a sphere made of steel. So what we do, that sphere has a little notch in its surface, and this notch allows the sphere to be inserted, at the tip of the projectile, and it stays there, at the tip of the gun, and it stays there. Okay. Here is the projectile launcher loaded. Okay, here's the projectile launch loaded. Remember, in principle, you could use your hand to load this gun here. In principle, you could, but it's not the advisable one because it hurts a lot. You could use your bare handle to load this tip here, right? This gun by pressing against the tip. But because the tip is so small, it produces too much pressure in your hand and it hurts. So instead, the advisable way and the practical way as well, because I have never been able to load a gun with just the tip exposed, just the exposed tip here. So the advisable way to load this gun is to first put the projectile, the spherical projectile, at the tip of the gun, and then use your hand to load it, because the surface of the sphere is much larger than the surface of the tip of the gun. It's much easier to load the gun and less hurtful and hurts less as well, right? with the projectile there at the tip. Okay, so that's how we load the launcher. And now that the launcher has been loaded, I can take out the sphere. Okay, in the experiment, it's very important that you do that, because if you keep the projectile in there, in the loaded gun, it's like keeping a bullet in a loaded gun, right? In a real gun. You can get hurt, right? If somehow the gun fires by itself, the projectile can hurt you. So I advise my students to keep the projectile aside, out of the tip. The gun is loaded, but there is no projectile. It's like having a real gun with no bullet there. And then what do we do next? We're going to use a photo gate. Okay, I'm going to tell you why we're going to use this photo gate. So we place a photo gate. You're already familiar with that from a previous experiment, right? Let's see here. Bubble level, right? A spherical projectile, one photo gate and a photo gate accessory. Okay, this photo gate is a device that measures the time, and this time measurement is used to determine the velocity of the projectile. That's the photo gate is all about. But it's a photo gate and it's accessory. Okay, here you go. It's accessory as well. I'm gonna show you a video of the photo gate so you can have a better idea how it looks like. Okay, remember, but what you should remember is that this photo gate measures time. It measures the time it takes for the projectile to pass the distance between those two gates. Okay, and the resolution of this photo gate is a tenth of a millisecond. Okay, a tenth of a millisecond. Think about that. Your timers in your cell phone has a resolution of a hundredth of a millisecond, but this thing is not a hundredth of a millisecond, a hundredth of a second, right? A hundredth of a second. So this thing is not a hundredth of a second. It's 2 orders of magnitude better than your cell phone. That's what the resolution of the photo gate is all about. 0.0001. Okay, just for comparison purposes, the timer in your cell phone has a resolution of 0.01 seconds, just for comparison purposes. So this guy here is 2 orders of magnitude, has a resolving power of 2 orders of magnitude better than your cell phone. Going back, and I'm gonna show you the video for a photo gate. Okay, this guy, that's the best video I saw there in YouTube. Okay, and this guy shows the photo gate, and you're gonna see exactly how it looks like. I do not know if I showed that. I showed to you before, but not in the detail that I'm gonna show to you right now.
Hey guys, Mr. Johansson here. We're at the dynamics track. Dynamic tracks are so fun. Let me show you how the
concentrate not on the dynamic track, concentrate on the photo gate. Here is the photo gate. Okay, here's the photo gate itself. And he's going to demonstrate how the photo gate is used to determine time, the time that this card goes through a given distance of the photo gate. Okay,
this works. We have 2 photo gates.
Okay, see here, here's the actual photo gate. Okay, and here is the accessory of the photo gate. Let me, I'm going to email, I'm going to send you the link to this video in the chat window. Okay, so if you want to watch that later on, save this link there. Everyone, link showing how the photo gate, how a photo gate is used. Okay, this is a YouTube link, and let's continue there with our Remember, there will be a quiz, right? When we cover this experiment. Here you go. Here you go, a photo gate here, the first photo gate, and its accessory right here. This is exactly this photo gate that we use in our experiments. Also, notice the screen of this photo gate right here, the LCD screen, right? The liquid crystal display of this photo gate. Notice that you have 0, 0, 0, 0, 0. Actually, you have a 0 dot here, okay? And what you see here are 1, 2, 3, 4 decimal places on seconds, okay? 3 decimal places is a millisecond. 4 decimal places is a tenth of a millisecond. That's the resolution of our device, okay? And let's continue with the video.
Here, right? On this dynamics cart track, we have something that'll block the photo gates. It's called a picket fence. Now on the top, you'll see the dark mark of different lengths, but on the very topmost one, we measured it and it's 2.5 centimeters.
Okay, what does it mean by block the photo gate? Okay, and it means the following. In this photo gate here, you have a little light that we cannot see by naked eye. We cannot see by naked eye because it's an infrared light. So we have a light source here on the inside surface of this photo gate that's illuminating a photo detector right in here. This photo gate works just like the remote in your television. Okay, the remote in your television also have a light source in the infrared range, which is invisible to the naked eye. And your television also have a photo detector there in your television. So when you point your remote to your television, you control your television with the light of the remote, with the infrared light of the remote. And here we have the same thing. You're not going to control. The only difference that you're not going to control, you're going to use this light beam to make a measurement of time, okay? The cart is gonna pass by the photo gate and this little picket fence is gonna block the light beam that goes through it. And the electronics is built in such a way that it starts timing how long this light beam is blocked by this picket fence, okay? You're gonna see how it works.
All right, so we want to convert that to meters.
Well, it's a nice toy, okay? What I like to say is this is a nice toy.
What do you multiply by? If you said 1, right? Well, you pick the form of 1 that'll change 2.5 centimeters into meters. So we can turn this into meters per second. Once this starts rolling,
whoa,
blocks,
okay. When it blocks, it's passing through the photo gate right now, right? One of those picket fences is blocking the light, the invisible light that's going through this fence. Okay, a photo gate, when the light is blocked, a red light turns on here. Unfortunately, we cannot see this red light. But every time that you block this light here, there another LED, a red LED turns on here to tell you, hey, I'm starting measuring. Now look at the screen, at the LCD screen here. It's no longer 0, okay? It's no longer 0. It's changing right now. It's changing the values in seconds. We'll keep on watching. Okay, do you see watch this screen when I play the video again? It's gonna keep on changing. Now we already have more than 1 second, right? 1 point whatever seconds.
Number 1, you'll see a little
2 seconds, right? It's changing to 3 now.
red light come on here.
See, he said about the red light, but we cannot see the red light in this video. There is a red light there, but for some reason the video doesn't show it.
Right?
And now, do you see what happened? That's one way to use the photo gate. That's one way to use the photo gate. The moment that the bar passed completely, the photo gate recorded a time interval of 5.3694 seconds. So this picket fence was blocking the photo gate for 5.3694 seconds. Okay. That's one way to use the photo gate, but there is the way I'm going to use for this experiment is different. Okay.
Photo gate number 2, you'll see a little red light come on there. So you can make sure the photo gates are the right height So they'll only be blocked by the top part of the picket fence, 2.5 centimeters. This timer is kind of a cool old school timer. When this first photo gate is blocked, the time that it's blocked for that 2.5 centimeters to go through it is given here. When it goes to the next one, you don't see a change in the display. Okay, so what you do is...
Okay, so we don't want to hear what he's going to say. What I'm going to tell you, but you want to know something. You know, this photo gate is being used just for one pass through the gate, okay? But the way we use our photo gate in the projectile motion experiment is that we fire a projectile, the spherical projectile, through this first gate, okay? And once the projectile passes through it, the photo gate starts timing it. That's another setting of the photo gate. And until the ball reaches the second photo gate, the time doesn't stop, okay? That's a different way of using the photo gate. You either pass the objects through one of the gates, or you pass and determine how long it takes for the object to go through one of the gates, or you set your photo gate to time how long it takes for your projectile or any object to go from one photo gate to the other one. That's how we're using this photo gate, okay? So that's what I want to show you about the photo gate, how it works. Okay, and don't forget, is 1/10 of a millisecond resolution. And here we have the two photo gates. One is the photo gate, the other is the accessory. The real photo gate has that little LCD screen, okay, that tells you how long it takes for the projectile to pass through this distance between the two photo gates. Here you go. In the experiment, we place those two photo gates at distance D. This distance D is 10 centimeters, and we measure it with the ruler. We measure this distance with the ruler. Now it's time for me to open my spreadsheet. Not this one. See here. Lake Harbor, Paul, raw data, lab number 4. Let's see. I'm gonna look at the number 3, right? Group number 3. Here you go. Here you go. We have this first table. Okay. And that's our first measurement, the distance between those two photo gates. We usually use it 10 centimeters. And we measure that with the ruler. We measure this distance with the ruler. Okay, first data. You put 9.8 meters per second square. You don't have to measure that. Okay, we measure that in another experiment. And first data of our experiment. Okay, ruler to measure the distance between photo gates. 10 centimeters. Resolution of the ruler, you already know, is a millimeter. We also use a masking tape to fix everything there. This is the setting of the photo gate that I'm talking about. The photo gate has 3 settings. One of them is the gate setting. Gate is the setting that the professor there in the video was using. What we use is the pose setting. Okay, in the gate setting, when we pass an object through the first gate, it tells you exactly how long it took for the object to pass only through one gate. In the pose gate, we have 2 photo gates. The time there in the screen tells you how long it takes for the object to go from one photo gate to the other one. That's what the pose setting is all about. And then we have a third setting that I'm not going to mention here, but it's a different setting, okay? That the object pass through the first one, goes to the second one, and come back to the other one. It's like to measure this frequency. Okay, so that's the distance D. All of that is spelled in that video that I gave the link for you, okay? To you, okay? So here you go. Anchor the photo gates on the table with the masking tape. Okay, that's what the masking tape is all about. We want to anchor the photo gates so they don't move with respect to each other and the distance here doesn't vary. Masking tapes are very useful tools in the lab, okay? Set the main photo gate to pulse. That will allow it to measure how long it takes for the ball to pass, the projectile to pass from one photo gate to the other one. Load the launcher with the projectile. What are we going to do now? We are going to find out what is the velocity of this projectile. We're going to find out what's the velocity of this projectile by timing how long it takes to cover this distance of 10 centimeters. D divided by delta T of the photo gate is the speed, the launch speed of the projectile. Okay? When you propel the projectile, it describes a parabolic motion, right? And impacts the floor right here. In the first part of the experiment, we are just measuring the time it takes for the projectile to move this distance so we can find the velocity, its velocity, okay? Next video, here you go. Fire the projectile 10 times. We do that 10 times and determine how long it takes to move between the two gates. Okay, calculate the initial speed of the projectile. It's usually 3 to 8 meters per second. That's the speed of the projectile. A human being, you know, the speed of the human being is like 1 to 3 meters per second. Okay, if you're walking, maybe it takes like half meter per second. If you're jogging, it takes 1 to 3 meters per second. And you can take a look here at the spreadsheet. Okay, remember the projectile is being fired 10 times and it goes through this distance of 10 centimeters. That's the first measurement, second measurement, third, blah, 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 10 measurements. Okay, it takes more or less 0.0163 seconds for this one to go through 10 centimeters, okay? The next one, 0.0171, it varies a little bit, 0.0167, 0.0166, and so on, okay? So what you're going to do, you're going to sum all those experimental results, and I'm going to take the average value of those measurements, okay? That's what we have here. Here's the average. Don't forget to put the units. We have to put the units here. I'm going to get to that soon. Hang in there. And here you go. V is calculated by dividing the distance by the average time. And you have between 3 to 8 meters per second. Okay? And don't forget the significant digits, right? 3 to 8 meters per second. 9:42. Let's go another 15 minutes, right? And then we have our break. We also have to measure the height of the projectile. You're going to need that to determine the range of the projectile, right? The range is the distance from here to here. And you're going to measure this distance and compare this measurement with the equations of projectile motion. Okay, here you go. You measure this height with a meter stick, which also has a 1 millimeter resolution. Okay, meter stick resolution used to measure the range and the height of the projectile. The height is why not use this resolution to enter this value here for the height of the projectile. Okay. What's the theoretical time for that? Okay, the theoretical time is given by a projectile under free fall. Okay. So let's see if I have the equations here for you, so you don't have to type them again. Okay, here are the equations of motion. the projectile moves with constant velocity along the x-axis because it's not accelerated along the x-axis, right? And the projectile is also uniformly accelerated along the y-axis. In this specific case, the initial velocity of the projectile along the y direction is 0 because the projectile is being propelled along the horizontal direction only. The vector velocity of the projectile is along the horizontal direction only. Okay, so that's what I did here in this equation. I cancel out this term, and I have only those two terms. And the initial position of the projectile is y0, which is the initial height. We want to know how long it takes for the projectile to reach the floor. That's why I'm doing that. What happens, how long it takes was t for y equal to 0, right? I made y equal to 0. And the time of impact, the floor is going to be given by this square root right here. That's the equation. And this result is substitute right in here in this equation. Okay, and then what I have, I change it from x to range. The range of the projectile is given by this equation. Okay, that's the equation that we want to verify experimentally. That's the theoretical result of the range, and we're going to fire this projectile 20 times, and we're going to measure this range to 25 and compare to this theoretical result. Okay, that's what, here you go. That's what XR is all about, range of the projectile. If you want to know the exact number, right, you have to change the format of this number. So have notes, you go, yeah, fire the projectile 10 times through the photo gates to measure how long it takes for the projectile to displace 10 centimeters. Calculate the initial velocity of the projectile. And that's what we did here, right? That's what we did here. Measure the height of the projectile it's launched. Projectile is launched. Why not? We did that. Predict the range of the projectile is the above formula. Okay, so going back to our lab notes. Oh, right here. We found out what the initial velocity, we measure y0, we know that g is 9.8, and that's going to be our theoretical value for the range. Fire, and then fire the projectile 20 times and measure each of these ranges. That's what the next table is all about. Firing the projectile 20 times. I can change the format here because it's not important. You go number with 0. Good. Now you can see measurement 1, 2, 3, 4, 5, right? 20 measurements. Let me erase that. You don't need that. Okay, clear. So it's 9:47. Let's see what else we have to cover here. Units, okay. Don't forget that's the equation, d divided by t average. Okay. And so what I want to do now for the next 20 minutes, I want to, let's see what we're gonna do. Now let's take our break and then we have our quiz, okay? Let's do that. It's 9:48 right now. Here you go. It is 9:48 right now. Let us take our break to 10:05 a.m. And after that, we will have our 20 minutes long quiz. Okay. So we're going to start at 10:05. We're going to go to 10:25. Let's do that. So I see you in 15 minutes, a little bit more than 15 minutes. Okay, and so what we have done so far. Okay, so we have done the following. Let me just summarize what we've done so far, so you can refresh your memory, right? So far, we have done the following. One, measure how long it takes for the projectile to travel 10 centimeters. Okay. Fired the projectile 10 times. Let's see, 10 centimeters. 2, calculated what is the initial velocity of the projectile from the measurements in item 1. Okay. Measured the height of the projectile. Why not? What I call why not? Let's see. Why not? This guy here is supposed to be why not, okay? So just fix that. The subscript. Okay, why not? Okay. Calculate the calculate the initial velocity of the projectile for the measurements in item 1. Okay. Measure the height of the projectile. Why not? Okay. With why not? With why not? The initial velocity and what else? Let's see here. Yeah, why not initial velocity and the initial velocity, comma, predict the range of the projectile. Finally, fire the projectile 20 times and measure the range. Okay. Fire the projectile. No, it's not finally, right? Fire the projectile 20 times and measure the range. And that's what this table is all about, right? So if you take a look. Oh, no, sorry, not this one. It's this one here. Okay, I made a distinction between XR and X prime R, okay? XR is your prediction. X prime R is your measurement. So it's around 2 meters. So if you go here and display number 1, 2, 3, you know, it varies a little bit from, you know, 237, blah, 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 right? Look here, how 237, 241, 6, blah, 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 right? So it's not exactly the same value, but it's close enough to each other, right? Then you take this sum, display everything with the proper significant figures. From this sum, you get the average value of those measurements. Okay? This number here should be close enough to this number here. Okay. The prediction should be close enough to the measurements. What else are we doing here? There's more. There's more to it, right? We're doing something else too. By the projectile, measure the range, measure each range you obtain. Right? Next, you do something else. Sort the 20 measurements of the range from the lowest value to the highest value. Okay. You do the sorting. And how do you do that? You know, you can either do manually on the side, or you can do using Excel itself. Okay, whatever you feel is more convenient for you. If you do manually, it's going to take a longer time. If you know how to use Excel, it's going to be quicker. Okay, so how do you do? First, you highlight all those data, and you go to all those cells, and you go to data. And then there is this icon here that allows you to sort the values. Okay, expand the selection. Microsoft found data. Since you have not selected data, it should be okay. Continue with the current selection. Okay, you're gonna have this screen screaming at you. You know, do not expand the selection. No, just continue with the current selection, and then you sort. Oh, G, let's see. Smallest. Make sure you have the smallest to the largest value. Okay. You also have the largest to the smallest. You don't want the smallest. You don't want the largest to the smallest. You want the smallest to the largest value. You click OK, and it should sort for you. Okay. So that's one more thing to put in our. Oh, already did that. Okay. So now that is sorted out, there's a reason why we're sorting it out, okay? And you're going to find out exactly why. We're going to do what else? We're going to calculate the standard deviation of your data. Okay? Do you know what's the formula of the standard deviation? Okay, that's standard deviation is just like a statistical parameter that we have out there. You should know what an average is, right? But then we also have this statistical parameter that we call the standard deviation. The standard deviation is a measure of how far away your set of measurements deviate from the average. Okay? It's a measure of how spread out your data sets, like this one of the range, is spread out from the average. Okay, and you gotta write down the unit for that. Gotta write down and so on. Right now, let's see what's this thing here. Oh, okay. What you see here is the percentage difference between the average values of your measurement and the predicted value, okay, using the equation. And we are getting what value here? We're getting a 4.7% difference. Not bad, right? 4.7. That's how good the theory is. It's less than 10%, even less than 5%. Okay? That's what this delta is all about. Now, what about sigma? Let's take a look at the equation for the sigma, okay? If you have a set of data, of values, of measurements, the definition of sigma, which is, like I said, called the standard deviation, is what? Okay? It is each one of your measured value, x prime r1, x prime r2, x prime r3, okay? Everything that's in that, minus the average, okay? So what is the standard deviation? The standard deviation is this value minus the average, you take the square. This value minus the average, you take the square. Sum those two. This value minus the average takes the square, and so on. That's how the standard deviation is defined. It's a very useful parameter, the very useful statistical parameter. And the equation is right in here. I'm going to, I'm going to spell that out for you. So it's that's the summation sign, right? But I'm going to put it, here you go. I'm going to put it in a more familiar way so you can understand. You take the summation of all those values, okay, to, oops, two, okay, three, until, 1, 2, 3, until 20. Do you notice that this value doesn't change? That's the average value, okay? Given by this equation here. Divided by n minus 1, and then you take the square root. That's the definition of the standard deviation. Let's take a look at the values of the standard deviation. Now, you gotta do dimensional analysis here to find out what's the unit of sigma, okay? You have to do dimensional analysis. I'm just gonna give you a hint here. This guy doesn't have any units because it's just the number of values. This guy has unit of what? Meter, right? This guy has the unit of meter as well. So what you're gonna get? You're gonna get meter here in this parenthesis, and you're gonna square meter. You're gonna get meter squared. You get meter squared here, you get meter squared here. And then you take off the square root of the meter squared, okay? Just a hint of how to find out the units of the standard deviation. Okay, going back to the spreadsheet, we calculate the sigma. Notice that the sigma is very small compared to the average value. The average value is 2, the sigma is 0.024. It's 1/100th of the average. That's how much the sigma is, that's how much your data is spreading out from the average, okay? And then you do something else, very important. You're gonna get the average value and sum with sigma. And then I'm gonna get the average value and subtract sigma. Okay? Then you do that for 2 sigmas. That's the reason why we do that. That's the reason why we do that. Notice that plus sigma is 2.467 and minus sigma is 2.419. So what do you do next? Remember that you have all this data sorted out before, right? Sorted out before. Let's put that in a way so we can read it more properly. Okay, here you go. See, it's sorted out from the smallest value to the largest value. In reality, in general, when we are doing the experiment, this data is not sorted out automatically for you. Okay, you have these values randomly distributed from measurement 1 to measurement 20, right? Let me write that down here. Measurement 1, measurement, why do I have to? Oh, interesting. Measurement 2, so on, right? Measure. Why do I have this formula? Ah, that's why I have this formula. Measurement 3 and so on. Here you go. And then what are you going to do next? You are going to look at this range of values, 2.4, the smallest one is 2.419 and the largest one is 2.467, right? And you write that down here next to your table, 2.419. 2.419 is after 2.417, right? So you write that out here, 2.419, right? And then you get the largest value, 2.467, which, which is, you write it next to the lowest value, 2.467, okay? Number, here you go, like that, okay? The lowest bound of your x average minus sigma, you put, next to the next larger number. The highest bound of your x average plus sigma, you put next to the lowest, to the next lowest value, okay? And then what else do? You count how many values you have here in between. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Okay? And with 13 values here, you go ahead. You write that down. The number, N stands for numbers, right? How many of your measured values do you have between X average plus and minus sigma? Okay? So it should be like 13. Okay, and here you do the same for 2 plus and minus 2 sigma. You have the lowest value and the highest value. Okay, that's how you're supposed to do this last part. So why do we do that? That's a neat statistical result that we find out there. When you have a distribution of data between plus and minus sigma, we usually get 65% of your measurements. Okay. And that's exactly what I'm getting here. For a normal distribution, we get something like that, 65% of the data. Here we get more or less 95%, right? So that's what you have to do. There is no graph for this activity, okay? Did you get the idea? Also, let me write that down here for you. It's best if we spell out in writing, right? Repeat how to find N. Okay. Sort your measurements of range from the smallest value to the largest. Identify the values XR average minus sigma. It should be prime here. X prime, because those are the measured values, right? Plus sigma. Highlight the values in your table of the 20 that are within those two values. Count how many highlighted values you have. Repeat for X prime. Okay, that I put here should be X prime, X prime. X prime stands for the measured value. The X stands just for the, and then repeat for minus sigma plus 2 sigma, okay? So that's what we have for this experiment. And I'm going to go through each one of you Make sure you're working on that. All this attendance here I got from the quiz that you people finished. Okay. Now I'm going to sort you out in terms of the group numbers. View, freeze pane, freeze pane. Good. Now data, sort, group number, cell values. Good. 26. Insert right in here. Okay, but Vanessa, are you in good shape there? Hi, Vanessa. Let's see if you're okay. Yeah, okay, good. So do you have any questions? What you have to do? No, you're good. Okay, great. Fisher, are you there, Fisher? I don't think Fisher is, right? Yeah, Fisher is not here. Blessing. What happened to Blessing? It's like Blessing left. Are you alone, Vanessa? Are you working alone, Vanessa? No? Is Blessing there with you? Doesn't look like Blessing is there. I'm gonna put a star here on Blessing. He's not gonna lose the quiz, but okay. Janet Garcia, are you there, Janet? Okay, good. Do you have any questions, Janet? No? Okay, we're gonna have a break very soon. Wendy. Okay, good. Wendy, are you there? Wendy's not here, right? Ryan Ong. Are you there, Ryan?
Yes, I'm here.
Okay, good. Do you have any questions?
No, I don't.
Okay, don't forget you gotta sort out, right? The values. And next is Mia. Mia, do you need anything?
No, I'm okay, Professor.
Okay, good. So let's see, that's group number 2. You have 3 students in group number 2, right? Group number 1, okay, group number 3, let's see. Group number 3, you have only 2 students there in your group? Ray and Joshua?
Yes, Professor.
Okay. So, okay, so do you have any questions?
Yeah, real quick. Can you just go over real quick of how to find n again? I kind of got lost when you were explaining
Okay,
it.
okay, so let's do that. Here
Yeah,
you go.
thank
Okay, basically what you want to know, you want to know how many of those values fall within x average minus sigma and x average plus sigma. That's what you want to know. That's all. Okay, so the x average minus sigma is this one here, 2.419. And the x average plus sigma is this one here, 2.467. Okay, so what are those values here that are within those 2 values? Okay, for 2.421 is greater than 2.419, right? And 2.460 is less than 2.467. The next value would be greater than this one, so you don't count them. All you have to do is to count those values that are within the x minus sigma and x plus sigma. That's all you have to do. Okay, identify which values among x prime are that fall within x minus sigma and x plus sigma. But of course, in order to do that, you have to sort that out, right? Did you sort that out? Did you sort
Yeah, I
those
sorted
values
that.
out?
I
You
sorted
did?
that.
Okay.
Mhm.
Okay, good. So you have almost everything. And then you do that for x plus and minus sigma, and then you do that for x minus and plus 2 sigma, right? That's all you have to do. Make sense?
Yeah, Professor, I got it. Thank you. Appreciate
Okay,
it.
good. Thanks. Okay, that's Ray and Joshua, right? Okay, you're there. Are you there, Joshua?
Yeah, I'm here. That was me speaking.
Okay, so you have only two students in your group, right?
That's correct. Yeah.
Okay, so group number 4 now. Let's go for group number 4. Lily, are you there? Okay, yeah. Here you go. Do you have any questions, Lily? No? Okay. Good. What about Michael? Do you have any questions, Michael? Okay, yeah. Do you have any questions? Or are you in good shape? Did you understand everything? Okay. Remember, there's no plotting, there's no graphs, right? And what about Daisy? Are you good too, Daisy? Okay, good. Next is Ana Lopez. I don't think Ana Lopez is here. Nope, Ana Lopez is not here. So let me just highlight those students that have only two students, right? And maybe I'll get you folks to 2 other students to help you out, okay? I'll get to you, Donia, hang in there. And it's not here. I just talked to Daisy, right? Mary, are you there, Mary?
Yes, Professor.
Okay, good. Do you have any questions, Mary?
No, Professor.
No? Okay, good. Jennifer.
Yeah, I'm here.
Okay, good. Do you have any questions, Jennifer?
No, I don't.
Okay. And then we have Alika.
Yes, Professor.
Okay, any questions, Alika?
No, I'm good.
Okay, good. Let me highlight this other group here of students. Pacheco, are you there? Okay, okay, no questions. Thank you. What about Brianna?
I'm here, Professor.
Okay, good. So let's see. Now, do you have any questions, Brianna?
No, I'm okay.
Okay, good. Basilio.
Hi, Professor.
Okay, are you good shape there? Do you have any questions?
Yes, I do. So I know we're supposed to compare the values and find the number of values that we're going to be using. But so it's XR, which is plus and minus what was it called? Not theta,
Standard deviation.
sigma.
Yeah, the standard deviation.
Okay, yeah. And now is there a way, because I don't know how to sort it. That's the only thing I didn't understand.
Let's do that again.
Okay.
Here you go. You know, those numbers are already sorted out. Okay, so let's do it here on the side so you can, see how it's done in format. I'm gonna just come up numbers. I'm gonna generate some numbers randomly here. Okay. So here you go. And then I will sort them out. Okay, I will sort a bunch of those random numbers. Okay.
Oh, okay.
Okay, but just for, well, those random numbers represent those numbers here that you need to sort, okay?
Oh, I see.
They represent, okay? So we're just gonna, and now what I'm gonna do, I'm gonna copy and paste them here so I can work with them. And I'm going to change them into numbers, actual numbers, so you can see them more easily. Okay, so what I want to do, do you see they're not sorted yet, right?
Yes.
Okay, they're not sorted yet. So how do you sort them out? Okay, you go ahead, highlight it. Okay, highlight it. Go to data. Okay.
Uh-huh.
If you're not in data, you're not gonna see sort. Okay, you gotta click here in data. And then there is one icon here that's written sort. Okay.
Oh, I see it.
Okay. When you click sort, he's gonna, you already have highlighted your data, and you're gonna make sure that you're sorting from smallest to the largest one, because you have other options. You can sort from the largest to the smallest. Okay. And then you have this custom list that I do not know what it is. So all you have to do is concentrate on this one, the smallest to the largest one.
Okay.
Once you click OK, look what happens to those numbers. Once you click OK, they are
Sorts them.
sorted. They sort themselves. You can do either that or you can do that manually, right? Okay.
Okay.
I don't recommend you to do manually.
Yeah, it'll take a while.
It's gonna take forever, right?
Yeah. Okay. Thank you.
No. Now, who was talking to? Was that Basilio?
Basilio, yes.
Yeah, Basilio. Okay. So Vahag, do you need any help, Vahag? Okay. No questions. Okay. Alejandro is not here, right? Amarilis, are you there?
I'm here.
Okay. Do you have any questions, Amarilis?
Yes. How did you make the graph into the numbers?
Well, there is no graph. Okay. There is no graph.
I mean the table.
Okay, the table. Okay, so all you have to do, right? Well, you have your table here, right? Make sure you put the numbers in there, right? You highlight, the table of XR prime, okay? Highlight it, right? You wanna sort those numbers. Okay, go to data and then click sort. Okay. If this window shows up, just tell them that you want to continue the current selection. Sometimes it doesn't show up, but this time it did show up. Okay, and then you sort. Column G is smallest to largest. Okay. Do you do it?
How you transform the numbers like 3.e plus 00 into the number.
Oh, yeah, here you go. Okay, what you have here was format cell, right? It was on scientific. That's what you have the number. Your numbers are showing up like that, right?
Yeah.
Okay, so now you want to reformat them, right? That's how I usually get the spreadsheet, right? You highlight the numbers here, right click, format cell, highlight number, and then put as many decimal places you see is correct, as you see fit. Okay? The number of decimal places is going to depend on the number of significant figures. Okay?
Okay.
Okay.
Okay, thank you.
Right click and then adjust the number of decimal places. And then you sort the numbers.
Okay.
Just one question. Are your numbers already sorted out there for everybody or not yet?
Not yet.
Yeah, because not yet. Okay. Yeah, group 3 already had that sorted out automatically. Right, group 3? Okay, so
Yeah, that's right.
Huh?
Did you say group 3?
Yeah, group 3. Your numbers were already sorted out right from the beginning, right?
Yeah, they were.
Yeah, yeah. Some of those numbers were already sorted out. Okay, so next is Yesenia. Do you need any help, Yesenia? Hi, Yesenia there? Okay, good. So next one is Labelud. Hello, Labelud. Do you need any help?
No, I don't have a question right now.
Okay, thanks.
I'm good.
Okay, Lydia.
I just have one question on ours for table 4-2 quantity unit. I know I see on yours for group 3, it says measure 1 through 20. Ours has the scientific numbers in the unit section. Do you want us to just rename that to measure 1 through 20?
Yeah, you don't have to, but you know. I
Okay,
think you don't have to. You mean this one here, right? This column?
yeah,
Yeah, you don't have to.
okay,
But
thank
if you
you.
want to do that, it's okay. Yeah. Mhm. Okay, were you able to sort everything?
Yes,
Okay, good. Lydia, right? Next is Justena Youssef. Do you need any help, Justena? Let's see, no, okay, good. And now we have another group. Let's see. Donia, do you have a group, Donia?
Yeah, I don't know. My connection was going in and out, but I've been here. Did you do attendance earlier?
Yeah, and but do you have a group for the lab?
Yes.
Which group is that?
It's group 3 or 4. Let me double
yeah.
check really quickly.
Yeah, double check
Sorry.
that, please.
Sorry, 1 second.
Mhm. Okay, while you look into that, let me just check with Jade. Jade, are you there? I don't have a, and you're alone in your group, Jade. It looks like you have just one person in your group, right? At least today, right? And what about Ashley? Is she coming? Oh, you are in group 4, you said. Or Ashley is in group 4. Okay, so I gotta change here to group 4, right? Just confirm that with me, please. Let's
Yes,
see.
group 4.
1, 2, 3. Okay, so group 4 has 4 students. What about Ashley? What happened to her? I don't see Ashley here. Okay, so let me, okay, so we have, how many groups? We have 2 groups with 2 students. Okay, let me see what I'm going to do. Donia is in group 4, not Jade. Donia is in group 4. Okay. Really? Jade. Let me see what Jade is. Where Jade is. Okay. Jade is in. Okay. In group 9. Where is the Jade? Let's see here. Okay. Yeah, okay. You are group 9, huh? So I was, okay, group 9. Okay, so we're talking about another group that has 3 students. And Donia, I need to know which group you are, okay?
I'm group 4.
4, okay. So group 4 has 1, 2, 3, 4 students, okay. So let me just sort that out, organize it properly, and group number, and now we have, okay, good. So 1, 2, 3 groups with 2 students. Okay, we're gonna do something about that, right? So that you don't be, let me think how I'm gonna do about those groups. And we try to sort that out by email, okay? For those groups that have only 2 students. Any questions? It's 11:15 now. Let's take another 15-minute break. Okay, and go. Break to 11:30 a.m. Okay. Okay, so. Okay, so let's take a break and I'll see you shortly in 15 minutes.